this equation says let f of x equal x squared. And so the following diagram shows part of the graph of f. So we've got our curve f, and it says line L is a tangent to the graph of f at the point a, negative k squared. So that means that this line here is a tangent, which means it touches the curve at just one single point, which is a. And then it says it intersects the x-axis at the point b. So the line continues down here, crosses here at b, and then it's also given us the point c, which is here. So part A says write down f prime of x. So we just need to differentiate it. So we know that f of x is this, so f prime is going to just equal 2x. Okay, next it says find the gradient of L. So we know that since this is a tangent, then at this point here, the gradient of L is going to be the same as the gradient of the curve at point A. That's going to equal m for the curve at A, so it's going to therefore equal 2 times by negative k, which is negative 2k. Alright, next it says show the x-coordinate of B is negative k over 2. So we need to work this one out here. So the way we're going to do this is we're going to work out the equation for this straight line. Since we already know it goes through the point A, which is negative k squared, and we also know the gradient, which is minus 2k, we can work out the equation for the line. And once we have the equation for the line, we can then substitute in y is equal to 0 to work out B. So I'm going to move down the page here and work this out. So B. So we know that the gradient is equal to minus 2k, and we know that we've got at point A, we know is negative k squared. So I'm just going to use the equation y is equal to mx plus c for a straight line. Substitute these values in, so I know what y is from here, I know what m is from here, I know what x is from here, and work out what c is to give me the whole equation. So I'm going to say k squared is equal to minus 2k multiplied by minus k plus c. So that's going to give me k squared is equal to 2k squared plus c. So hence that's going to give me c is equal to k minus k squared. Alright, so then my equation for the line is y is equal to minus 2kx minus k squared. That's the equation for line L. Then I know at B, y is equal to 0. So then I can substitute 0 into that. So I can say 0 is equal to minus 2kx minus k squared, and then work out what x is. So I would have k squared is equal to minus 2kx, cancel out a k, and I would then get x is equal to minus k over 2. So that means B, at B, x is equal to minus k over 2. So B is equal to minus k over 2, 0. Alright, let's see what we've got to do next. So then it says find the area of triangle ABC. Find the area of triangle ABC, giving your answer in terms of k. So we've got this triangle here, this triangle here. So I can draw on a line down here, this line here, and I know that the height this side of the triangle is k squared because this goes from 0 up to k. So this side here is k squared. I know that this point here is minus k over 2. So I can also see that between here minus k over 2 and here minus k, this distance here is k over 2. Alright, so then the area of the triangle is going to be half base times height. So C, area of ABC is equal to 1/2 times base times height, which is going to be 1/2 times by k over 2 times by k squared. Now that's going to give me k cubed over 4. Alright, next and it says the region R is enclosed by L, the graph of F, and the x-axis. This is shown in the following diagram. Okay, so I've got my diagram here. And it says, given that the area of triangle ABC is P times the area of R, find the value of P. So what I need to do here is work out the value of this area here. So what I can do is, if we consider this entire area under the curve here, that area there, that is going to be the integral of x squared dx between 0 and minus k. No, I've got my limits around the wrong way here, haven't I? Between minus k, 0 at the top, minus k at the bottom, dx. So that red area there, then what I'm going to do once I've worked that out is I can then subtract the area for the triangle, and that would give me the area of R. So I'm going to start off by working out the area of this red section here using this integral that I've written here. So if we go back down here, part D, so the red area is equal to the integral between 0 and negative k of x squared dx, which is going to be x cubed over 3 between 0 and negative k. Now if I stick the limits in here, when this is 0, this is just going to give me 0, and when this is minus k, this is going to give me minus k cubed over 3. So that is going to equal 0 minus k cubed over 3, but minus k cubed over 3, because I subtract this one from this one, so that's just going to give me k cubed over 3. Okay, so then area R is going to equal k cubed over 3 minus the area of the triangle, which I can see here is k cubed over 4. Okay, so I can turn those both in over 12. So that's going to be 4k cubed over 12 minus 3k cubed over 12, which is just going to be k cubed over 12. So then, area of ABC is equal to the area R multiplied by P. So this area here is k cubed over 4, and this area here is k cubed over 12, and then P. So I can therefore see that P is equal to 3. Alright, this area here multiplied by 3 would give me this area here. Alright, the area of this triangle here is 3 times the area of R here.